shall we? After the last few times I reached out to ChatGPT and asked it to update the list of the problems because a lot of them were involving dynamic programming. I want to focus on a more diverse set of problems. And also some of them were a little bit too hard, which is good and bad. So I also asked it to make it a little bit more palatable. So yeah, here we are. Let me share my screen. And let me choose the correct layout. Now the problem today is the number of islands. I solved it once, a long time ago. I think I solved it once. Let's see. Yeah, basically almost 2 years ago now. So shouldn't count for much. But I already have an idea about how I should be solving this if I remember this problem correctly and if I can figure out what the problem is about just from the name. So today it will be more about me explaining things and less about me trying to figure out things. But still, the implementation of graphs is always tricky here or there, so that's another thing to keep track of. Okay, given an 2D binary grid which represents a map of ones and zeros, okay, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. And you may assume all four edges of the grid are all surrounded by water. This makes sense. So we are given map, which is it grid? No, grid. Which is a list of strings. Here everything is represented by string 1 and string 0. And we need to return an integer, which is the number of islands. So let's create some tests. First of all, what if we have an empty list? I think it will be like just 0 islands. What if we have, now I will stop writing brackets to make things simpler. What if it's just like 0, 0, 0, 0? That's our map. Then in such case, the answer is 0. What if it's 1, 0, 0, 0? In such case, the answer is 1, because we can assume that all four edges are surrounded by water. So even though this is an island on the border, it's still considered an island. Okay, now another scenario. This is obviously still just one island because those two pieces are connected, but this scenario would give us 2 islands because yes, only horizontally or vertically counts for connection. Okay, and then there can be many more possible combinations, and let's just maybe write something like 1, 0, 0, 0, 0, 1, 0, 1, 1. So this is also a map with 2 islands. Okay, so solution. First of all, we have a lower bound for our runtime complexity. We will have to visit every cell of our matrix at least once. So it is at least of NM best possible solution in runtime. So if we can get to O of NM solution, that would be great from the perspective of runtime complexity. Then there is another issue on space complexity, right? So we can update this matrix in place, I think, in some clever ways, so that we can solve it in O1 auxiliary space. But this is not a good practice, like modifying the input, mutable input especially. So I wouldn't want to do that. I think it's cleaner to solve it in O of n m space. Why do we need this space? We will need to store all the cells in the map that we have already visited. Okay, so now what would be our solution? Essentially, we want to start with each of the cells on this map, and this cell will either be 0 or 1. If it's 0, each cell 0, continue. So we don't do anything in this case. 1, we start DFS from this point. We can also start BFS, it doesn't matter much, but because both of these algorithms will have the same complexity. But I will use DFS here, and we will be exploring the connected cells connected to this one. So if a connected cell is not visited and is 1, we are jumping to it and continuing the exploration until we explored all the possible cells that are connected to this one. So this will be all one island. And once we exhausted this island, we will basically be once we have started or once we have exhausted an island, we will increase the counter of islands. That will be a separate variable. I think better to do it when we start. So then we continue iterating overall cells. And if we are exploring islands, obviously we mark cells as visited. So if we come and try the same island again, we will just move on. And essentially, this splits our problem in 2 parts, right? First part is starting at each of the cells, and it will be of n times n runtime. And then the second part will be DFS, but for each cell, it can only run once. So it will be still O of nm in total. So it will be aggregated O of nm plus O of nm. So in total, it will be O of n times m runtime, which is great, which is the best possible solution in this scenario. So I think this is the one that we will going to try to implement. Increment the counter and increment the counter. Okay, so this is basically the idea for our solution right now. Of nm runtime, to be clear. So here we will be doing implementation, and let's start implementing this. Okay, let's start by saying that n and m is the number of columns and the number of rows. So it will be length of grid 0 and length of grid. And now we will define DFS. And for now, this will be, okay, we will be passing row and column. And both of these values will be integers. Integer, integer, and we will be returning none. For now, we will just pass here. Another thing that we want to keep track of is visited, which will be false right now for every cell. So it will be false times n columns for this in range m rows. Okay, so this is visited, and finally total islands will start with 0, which is important because of this corner case. the default value that we are returning for an empty map is 0. Okay, we will be implementing DFS a little bit later. Right now, let's implement the rest of the function. So for row, okay, yeah, let's say for row in range M, for call in range N, if not visited of row and column, so if the cell is not visited yet, then we can figure it out. There are two scenarios. If grid of row and column equals to 0, okay, first I think either way we are visiting this cell. So should we mark it as visited, or will we be marking it visited in DFS? This update, if we make it true, is idempotent, but either way, I think we will be doing it in DFS. So first of all, visited row column here will become true. So we don't need it if we start visiting it. So if it's 1, we will be visiting it. So else we will be starting DFS from here. So it will be DFS row column. But if it's not visited, just to keep things clear, I don't think we will ever go back to this cell, so we can just leave it as false, but let's mark it true, just so that by the end of it we always have invariant that once we have considered cell in this loops, it will always be considered visited afterwards. Okay, so now we do DFS of row column, and that basically means that we have started exploration of a new island. So this will be total islands plus or equal to 1, and then we are returning total islands. But now we need to figure out how exactly this function works, right? Okay, so we will be trying all possible directions. So directions equals, we can travel 0, 1, or we can travel 1, 0, or we can travel 0, -1, or we can travel -1, 0. We need all 4 directions, even though we are traversing from the top left to the bottom right. We can start traversing some island that has strange spiral shape, so we can theoretically move in each direction and it will be not visited at this point of time. So for each of those directions, for delta row, delta column in directions, so we need to consider several things. First of all, these should not be out of bounds. For any of the grids that we have 2 grids, like grid and visited, and they're the same dimensions, fortunately. So we will need to check if first clause here is, I think we should just be clean right away. So if 0 is smaller or equal to row plus delta row, and strictly smaller than M, and 0 is smaller or equal than column plus delta column, and strictly smaller than N, and now what next, right? Next, we need to check two things. First thing is that it's not visited yet. Second, that it's also one. So it basically means that it continues the same island. Okay, so now, and let's check first for not visited. And it will be row plus delta row and column plus delta column. And finally, and grid in the same place is equal to 1. We are continuing the exploration in such scenario. So we do DFS of row plus delta row and column plus delta column. Okay, so now this looks good. And I think that's basically it. Let me now try to check this scenario here. So this is our island. So let's figure out how this algorithm would work for this particular island. So n and m, should I make it, yeah, let's just for the sake of it make it not a square so that we can catch more issues. Maybe let me change it like this. This should be simpler and faster to check. Okay, so now we have n, which is number of columns, which is 3, and m, which is number of rows, which is 2. Visited is false, 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 and false, false, false. Okay, total islands is equal to 0, and we start iterating. So we start iterating over rows first and columns second, so we will go row by row. We started the first element, and this element is not visited. So we follow here. And here we see that it's not 0, so we are continuing here, and total islands become 1. Now we are starting DFS from this cell. So first of all, DFS changes this to true, that is visited, and then it considers directions, basically all 4 possible directions. So first, let's say it considers this one. It is in bounds, so we can check if it's visited, it's not visited, and if if grid here is equals to 1, no, it's not. So this is not true for this, so we don't continue exploration here. Now we're considering this, and it's the same situation. It's in bounds, everything is good, but it's not 1, so we stop exploration here. And then we continue exploration in this loop. So we continue here, and it becomes true, but it's 0. So we just mark it true, that it's visited, but don't continue the exploration further. Now it's 1. So again, we start DFS, and the first thing that DFS changes is it makes it true. Now we go in different directions. So we try this direction, it's already visited, so we don't go there. Then we try this direction, it's visited, it's not visited, and it's 1. So we continue here, and we continue depth search. Now this is true, and we consider all possible directions. So the previous one that we came from is already visited. The one on the left is 0, so we don't continue exploration anywhere. DFS returns to the previous DFS. Now DFS returns again to the previous DFS. And here we will be, okay, so there are just two DFS. So we return and we return again because we have exhausted all possible directions. There will be more directions, but they will be out of bounds. And we have, I forgot, we have increased the total number of islands here by 1. So now we continue exploration, we continue on the second row. So this becomes visited, but it's 0, so we don't do anything. This also is not visited, so it now becomes visited. And then it's 0, so we don't do anything else. And at this point we go here, and this last cell is already visited because it was the island that was previously explored. And the number of the islands is correct. So this solution looks good. Let's check that it works. Yep, finally. Good. We have finally made a solution that is a good one, that is possible. But probably there will be more questions after we have implemented this. And how much time? Yeah, 20 minutes. So that's it for today. See you tomorrow.